Hey everyone, Mr. Voikin here, and let's take a look at Lesson 5 in Unit 6. We're going to be dealing with the difference of squares, and you need to be able to sort of keep this in your mind and recognize when we have a polynomial that is a difference of squares. And you'll notice it because we're basically going to have a polynomial such as this one, a squared minus b squared. Now, what's essential is that this first term is a perfect square. The second term is a perfect square, and it is separated by a minus sign. And in this case, we break this down into two binomials, a minus b times a plus b. Okay, so keep in mind that the first term and second term have to be perfect squares, and it needs to be separated by a minus sign or a subtraction sign. So we're going to take a look at class example A, 1A. We know we're going to break this down or bust it down into two binomials. And we can see, is the first term a perfect square? Yes. Is the second term a perfect square? Yes. And is it separated by a subtraction sign? Yes. So I can set it up as so. A minus and a plus, and we take the square root of 4, which is 2, and that's done. So the same thing would be done in question example B. So it'd be t minus 12 and t plus 12. And in C, same thing. We have a subtraction sign in the middle, and on the outside, x squared is a perfect squared and y squared is a perfect square. So the only difference here is that we don't have a number in the second position, second term of that binomial right there. So, but this will, again, bust down to x minus y and x plus y. And again, you can just use FOIL and expand that, and you would get back to the y squared minus, or x squared minus y squared. So let's take a look at the final one, example D. Again, I've got p minus and p plus. This time it says 7 squared. Now 7 squared is, the number 7 itself is not a perfect square, but 7 squared will be 49, and the square of 49 is 7. So yes, it's 7 minus 7 and 7 plus 7. Okay, so the class example 2, it just says factor if possible using the difference of squares method. So the first thing you would want to go through and just check subtraction, 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 addition on this one. So right away we know that's not possible using the difference of squares. And the last one is subtraction. Then you want to just check each one. Is 16 a perfect square? Yes. Is t squared a perfect square? Yes. Is 49 a perfect square? Yes. And you would go through and check each one of these out. And so far, looks like they're all turning out to be perfect squares. So now it's just a matter of setting up those brackets to form two binomials. So in each case, we're going to be forming two binomials. The first one's going to be 4t minus 4t plus 7 and 7. The second one's going to be 9a minus 9a plus, and the square root of 1 is 1. And the next one is sort of reversed. You've got the number first and then the variable with its exponent second, but we'll still set it up the same way. It's going to be 10 minus 10 plus y and y. So let's take a look at the D and F, ignoring E because of that plus sign that's in the middle, indicating it cannot be factored using a difference of squares. So the first one on D would be 6p minus 6p plus 25q, oh, not 25q, pardon me. That'd be the square root of 25 is 5q and 5q. And the last one would be 8 minus 8 plus square root of 9 is 3. Square root of a squared is a. Square root of b squared is b. So minus 3ab and plus 3ab. Okay, and that's it for number 2. All right, well, class example 3, it's been easy to this point, and now we're into everybody's favorite word problems. But let's just, do what we're supposed to do and break it down, take it slowly, step by step, and double check, make sure we're doing everything right. So what does it say? We've got a floor. It's a squash court, not really important. It's rectangular in shape. And it has an area that is equal to 25 squared minus b squared, and the units are squared feet. Okay, so it says write an expression for the length and width of the floor. So you should be able to recognize that we've got a perfect square right there. And so we're basically going to break that down into two binomials. So we're going to have 5a minus and 5a plus b and b. Now, normally when you're talking about a rectangle, we would consider that to be the length and that to be the width. So the longer of the two is the length, which would be most probably this one right here, 5a plus b, because if I have 5a minus b, it's going to be a little bit smaller. So let's label this one as our length, and that one is our width. So what I have is the width. Whoops, what happened there? Come on back, thank you. The width, oh, I guess it won't let me move that. Okay, well, the width, I'll do it down here, equals 5a minus b, and the length is equal to 5a plus b. Okay, now let's break down part B. It says we've got a perimeter. So you need to know what a perimeter is. Well, a perimeter is the length all the way around the shape of an object. So we would start right here and we would go to there and there and there and there. So basically the distance of two widths and the distance of two lengths to take us all the way around and back to the beginning of this shape, this rectangle. Okay, so, and it says that if we did that, that equals 140. So the perimeter is 140 feet. Okay, determine the length and the width. So that's what they want us to do. Determine the length and the width. And it gives us a little bit of information here. The length is 1.8 times the width. So almost twice as much. The length is almost twice as much as the width. So in order to solve for this width right here and this length, we need to have values of a and b. Okay, because we're trying to find a numerical value for the width and a numerical value for the length. So let's start off with the first bit of information they give us there, which is that the perimeter is 140. And I know that two of these widths plus two of these lengths is going to give us a 140. So let's set that equation up. 2 times the 5a minus b plus 2 times the 5a plus b is going to equal 140. Okay, so notice that we've got two variables, an a and a b, which is normally impossible or very difficult to calculate that. So we're hoping that in this expansion and we'll expand these, and then we will gather like terms, and hopefully at some point we eliminate either the a or the b, leaving us with one variable. So first of all, we got 2 times 5a, which is 10a, plus 2b, and I'm going to add to that the 10a plus, one of those should be minus. What is it? This one up here. Sorry about that. This one should be the width, which is 5a minus b, which would make a minus 2b right there. And over here I got 2 times b, which is 2b, and that equals 140. So if I recognize over here, I've got negative 2b and positive 2b, so they're going to cancel each other out. I've got a 10a and a 10a, which is 20a equaling 140. Divide that by 20, divide that by 20, and we get a equals 7. So right now we know that a is equal to 7. However, that's not enough. I also need to figure out what b is equal to. Okay, now using the perimeter right here is going to eliminate the b, so that's not going to or help us out to solve the b. So let's use that other piece of information. So you'll come across this quite often in math, where it's saying that the length is, and is like another word for equals. So the length equals 1/8 times the width. So its length equals 1/8 times the width. So it's just that written in words above. So let's write that out like we see it there. So the length, which is 5a plus b, is equal to what? Well, just lost my battery. I'll be back. All right, I'm back. Let's see, where did we leave off? So we're trying to say that the length is equal to 1/8 times the width. So the length was 5a plus b, and that would be equal to 1.8 times the width, which is 5a minus b. All right, so let's just expand this one out and gather some like terms and see if we can solve for the b. So in this case, I have 5a plus b on one side equals 1.8 times 5 is 9a minus 1.8b. And we're going to move the a's from the left over to the right. So we're going to go minus 5a minus 5a. That's going to cancel it there. We're left with b equals 4a minus 1.8b. Now I can move this b to the other side by going plus 1.8b plus 1.8b. And now we've got canceled on that side. And we have, now don't forget that this is 1b right there. So we've got 1b plus 1.8b giving us 2.8b. And that equals 4a. Now, again, we're at this point, we have two variables. So what are we going to do? Oh, hey, look at that. Tells us right there that a equals 7. That's that same a right there. So I just need to replace that a with 7. So essentially we're saying that this is equal to 2.8b equals 4 times 7. So we got 2.8b equals 28. Divide that by 2.8. Divide this side by 2.8. We're getting the value of 1b is equal to 10. Okay, so now we got b is equal to 10 and a is equal to 7. So we just need to go back to our original information, which is right here. And I'll just copy that. Head up to the next page right here. Finish this question. Okay, so we had this, and we just determined that a is equal to 7 and b is equal to 10. Now I just need to substitute. So for the width, we get 5 times a, which is 7, minus 10, which is going to be 35 minus 10, which equals 25. And for the length, we get 5 times a, which is 7, plus 10. So that's going to equal 35 plus 10, which equals 45. So we're getting the width equals 25 and the length equals 45. Now don't forget that those units are in feet, so I would need to include that information to make the question 100% correct. And let's just go back to the question, make sure we're asking it. Determine the length and width of the floor. Did that. Now, how do I know if I'm right? Well, I could always go back and check out this perimeter. So I know that 2 times the length and 2 times the width is equal to 140. So I can just do a quick check. So 2 times the width, which is 25, plus 2 times the length, which is 45, should equal 140. So I get 2 times 25, which is 50, plus 90 equals 140. 140 equals 140, and we're good. There we go. All right, so let's take a look at the last class example, number 4, and it says we've got some polynomials, and hopefully we're going to be able to factor them. Recognizing that they are perfect squares. Right now they are not. You can see that 2 is not a perfect square and 50, both in example A, are not perfect squares, but I can divide 2 by 2 and I can divide 50 by 50. So the first thing I'm going to do is pull out that 2. I'm going to be left with a squared minus 25. Now I've got the correct format in there where I have the subtraction sign in the middle, and I can a squared is a perfect square, and 25 is also a perfect square. So I'm going to rewrite this down as, we're going to say that's equal to 2 times a minus 5 and a plus 5. Okay, for example B, notice that we can pull out a 3 out of both those terms. So I'm going to pull out that 3, leaving us with x squared minus 4y squared, and that will break down into 3 times x minus 2y and x plus 2y. Okay, let's move on to C right here. Now this one right here, you can notice that 144 is a perfect square. 12 times 12 is 144, and 4 is a perfect square, but they can also be, both of them can both be divided by 2 as well. In fact, both of them could probably be divided by 4. So if we were to take 144 and divide it by 4, notice that 4 goes into 14 3 times, leaving us with 24 left over, so 36. So I can pull 4 out of both of those. So essentially I'm going to pull out a 4, leaving myself with 36 p squared q squared minus, now 4 divided by 4 leaves us with a 1. So I still have that 4 that's pulled out, and it's going to be 6 pq minus 1 times 6 pq plus 1. All right, and on to the last one. It says we have letter D, 3x cubed minus 27x. So right now I got to pull out a 3 and pull out an x. So pull out a 3x, leaving me with x squared minus 9, and that can break down into x minus 3 and x plus 3. There we go. All the examples are done. Now it's time for you to work. The at-home assignment, you got 3 questions to bring to class next period. Letter A says 121a squared minus 36b squared. Letter B is 7x squared minus 7b squared. And letter C is p squared q squared minus r squared s squared. And then in class, we will work on questions 1 through 14 on pages 350 to 353. Answers are in the book. See you next class.